Western civilization is moving closer to a point of irreconcilable, unstable equilibrium, as frighteningly increasing numbers of people trust nothing. Media, academia, and especially the governments are no longer held in high esteem. Regaining trust is often impossible after betrayal. However, transparency is essential to any healing process, and that is the essence of the Don Sullivan Show. Please listen to the team explore, probe, and debate cutting-edge science, technology, and computing. Play ball! Hello, folks. Again, welcome to the Don Sullivan Show. So glad that you all are here to listen to our intended and continuous discussions of science, technology, computing within every single concept that falls within that umbrella. And today, we got to start off. The lawyers are making me state a release, so I'm going to state and say the release first. And if anybody has anything to comment on that release, we can. But all statements by the host and the guests on the Don Sullivan Show are the personal opinions of the hosts and guests, who all agree that the following content is the property of Xanalytics, LLC, to be used publicly and exclusively on the Don Sullivan Show. And with that, I want to introduce our guest today, Sudhir Balasubramanian. Excuse me, Sudhir. I'll say it again. Sudhir Balasubramanian. I had to practice that when we first met in 2012, but I haven't said it wrong in about 10 years, so I truly apologize. But we're going to have a good time today, and we're going to talk about databases. Sudhir is a true database expert. Sudhir is particularly an Oracle expert and has been with me at VMware for a very long time, for well over a decade. Sudhir has a great history in terms of the relational database model, and is going to have a lot of interesting comments that we're going to talk about in regards to the future of the relational model as compared to other types of approaches at storing data, especially in the context of 2025, in which you have enormous power within the processing that allows for data to be manipulated and data to be managed and data to be accessed outside of the spectrum of the protection of the ACID properties of a relational database management system. ACID standing for atomicity, consistency, integrity, and durability, which we might get into a little bit more later, but we don't necessarily have to, because we're going to keep this at a pretty high level. Again, the basic idea here is that we want to talk about, on the Don Sullivan Show, science, technology, and computing on a teenage level. And we say a teenage level because we believe that all of this, everything that we discuss, especially everything that's gone on in Silicon Valley over the last 75 years, is concepts and theories and ideas, technology that your average intelligent teenager could grasp and could work with under the auspices that our schools taught it properly. So with that, I want to introduce my sidekick and buddy and partner in the effort of the Don Sullivan Show, Jersey Steve. Say hello, Jersey Steve.
Hey everyone, it's a beautiful, bitterly cold day in New Jersey, and
it's gonna be worse in the next couple of days.
Yeah, I love the topic of databases. You know, they used to call me the database kid.
Database kid. Now you're Jersey Steve. You've grown up. That's wonderful. All right, Sudhir, anything else you want to say about yourself in terms of introducing yourself, or is that enough? You're the database guy. You're a database guy working with me at VMware for a long time. Say hello.
I think you said enough. So thank you guys. Thank you for having me on the show. Great to be here. But yes, it's great to be here with Database Steve as well, or Database Kid.
So, Database Steve. It's Jersey Steve.
Jersey Steve. That's the first I've heard of. Okay, that's great.
Been called worse. Whatever you like, Sudhir.
You're in Jersey. You've been called a lot worse. I know. I have.
Just as an FYI, it's bitterly cold here as well in San Diego.
Bitterly cold in San Diego. It almost hit 64 today, I think. So Sudhir, you all in the audience, you can't see him,
That's
but he's
beach
dressed
weather.
up. He's got a full knit hat on and a hoodie. He's looking, like a San Diego version of Bill Belichick at the moment. So
I have
we
our
go.
state outfit of a tank top on.
Yeah, no mosquitoes around and all of that. All right. So let's get to this discussion, because this is, again, science, technology, and computing. This is the computing and the database side of, or database category of our discussions. And Sudhir, I want to start it right off and really tap into your extensive background and your ability to predict the future in regards to how data is going to be managed, but from the perspective of the relational model and the relational database management system. So we all know that the more the huge companies that have been created based on the relational model and relational database management system are Oracle and Microsoft SQL Server from years gone past. You, of course, had Informix and Sybase and others, and even DB2 has
DB2.
a relational model as well. Data as a database that's based on a relational model, a version at least of DB2, and we'd really like to know what you think about it. Let's talk about how data relates to data in terms of relational database model. How would you describe it to this audience?
I mean, if you take a step back and look at it, right? I mean, essentially, what we collect is information at some point of time. When we start collating information in certain structured format, that's what a database really is, right? And when you start talking about the word relational, you introduce concepts as the foreign keys, or the entities that basically join parent and child table. For example, right? Let me just give an example here. Let's say you have a company and then you have a department, and the department has a couple of employees, right? So in this example, the department would be the parent table and the employees would be children, or would be child records of the parent table, by with the department ID being a key, right, or an attribute in the employee record that has a allegiance, or that has a reference to a record in the department table. So essentially, by these foreign keys, by these parent-child table entities and attributes, you're able to store data in a normalized fashion. And by normalized, I mean, avoiding redundancy, making sure that you're able to get to the data fast, right? And hereby making the database performant. So relational database, in a nutshell, pretty much refers to data being stored in a normalized fashion. And of course, when you start talking about normalization, you have like 6 or 8 levels of normalization, right? Starting with the first level of normalization all the way till 6. Typically, people go up to like the 3NF or the 3.5 NF.
I think you're talking about the Boyce Codd normal
yes,
form.
the Boyce Codd normal form, right? Essentially, where we say that every column has to be a scalar unit, cannot be a compounded unit, which means you cannot have multiple values in a column, right? So and then you have all these concepts to make sure that data is not redundant, right? That
I think the definition is
from data.
That every column within that table has to be dependent on the primary key and only the primary key.
Only the primary key.
That's the definition of Boyce Codd normal form, which is beyond third normal form. That's interesting. The word normalization, of course, within science, within mathematics, and so on, is used in so many different ways. And the truth is, if you go way back to the 50s and so on, you had models like the codicil model or the networking model. And then you got into the 60s, and the entity relationship model was developed with guys like Peter Chen and Boyce and Codd themselves, in which they were able to create or discover, is a better way of putting it, what is now referred to as relational calculus and relational algebra. And one of the things that, and again, I seem awfully old school when people talk to me about this, is when they say that there's no need for the relational model anymore. I tell them that the relational model is going to go away about as soon as algebra does, because the relational model is really all about how data relates to data. And that's all. And the relational database management systems, being based on the relational model, they create a system of databases, which is really the definition of a database, but a system of databases, depending on the individual product, that guarantees those asset properties that I mentioned before. More importantly, just referring to it as real, true data integrity. But we have an enormous system, an enormous internet, an enormous basis of data that exists in the world right now, that much of which, and hazard to say that even the majority of which doesn't need the protection, doesn't need the integrity, doesn't need to be managed by the complexity and even the overhead of a relational database. So, yeah, Sudhir, tell me about some of these other non-relational database management systems, or shall I say, relational data systems, data management systems, without calling them databases, because I don't think you really should, and how they. Tell me about some of those approaches, some of the things that you've been working with and are working with now.
Yeah, so essentially, I mean, if you take a step back and look at it, right, you have the DBMS or the RDMS, and then you have another genre known as the NoSQL, and the NoSQL basically stands for not. It's not a SQL, right? So it's essentially.
So tell us what SQL is. Tell us what SQL is.
So SQL stands for Structured Query Language.
It's not a language, right? It's not a language. It's just a set of commands. Isn't that true?
Set of commands that you would use to retrieve sections of record, attributes, columns from a table, right? Basically, you would then perform some operations on it, right? That could be, for example, select, let's say, the employee ID, the employee name, the employee address, the employee salary from an employee table. And then maybe you would be using that to do a couple of joins, couple of unions, Cartesian products, so on and so forth. That way you're able to come up with a report that you're able to show to your boss or your manager. So
that Cartesian product, that sounds an awful lot like an ancient mathematician, Rene Descartes. I think Monty Python said Rene Descartes is a drunken fart. I drink, therefore I am. Is that the same guy?
Yes.
It's the same guy. Oh, okay. All right.
So you're back to relational algebra, you're back to relational maths. That's what RDBMS typically, that's what RDBMS really is, right? So on the flip side, you have the NoSQL, right? In which case the NoSQL is completely, I would say it's not an RDBMS, right? Because what happens is, and here's the use cases. When you have structured data that you want to give some amount of structure to the data, you basically use RDBMS. And where you have unstructured data, for example, large object binaries, you have, let's say, images, you have text, you have spatial data, you have graphs, right? Let's say you have visuals, let's say you have audio images, right? So those kind of data are basically non-structured. They fall into the unstructured format, right? That's where you will use a non-relational database to store them, right? And even in the non-relation database, you have, many such non-relation databases. For example, the key value database, where essentially a record would just be a key and a value. So, for example, name, Don Sullivan.
Key pair relationships.
So that's one of them. The other one is a document store, where you would store, data as part of documents, not Word documents or text documents, but in a document fashion. So, for example, XML or a YAML or a JSON, a JSON type, right?
And all that stuff. Different ways of storing data.
Different ways of storing different types of data. You also have the column store data, wherein if you look at the RDBMS, typically data is stored by rows, right? You retrieve data by rows. In column stores, you retrieve data by columns. So it's column oriented. So where you want stuff to be retrieved very fast, you then would probably go for the column store databases. And last but not the least, the graph databases. And graph databases are very powerful. So, for example, if you have these
node entities, tell us. I've never heard of them.
Think of it, right? For people who would like to see visualization, right, where you want to see the relationship between nodes and entities, graph data are very, very, very powerful, right? So, for example, if you want to find out, let's say in a zip code, right, how many people they use AT&T, how many people they use T-Mobile, how many people use another provider, right? The graph databases basically help you show that data visualization, right? And so, for these unstructured data, you have these NoSQL databases that companies around the world, cloud companies and other companies as well, they provide either these databases or variant of these databases.
So unstructured, you mean different types of data, pictures and yes, documents and so on, just not just text.
Yeah, perhaps it would be helpful for our audience members that are not I guess I would use the word database savvy to point out maybe some use cases they might see in the real world in terms of when they might be doing something that interacts with a relational database versus, when they might come across, not that they're going to know it, but when they might be doing something that's utilizing a NoSQL database.
Right. And let me give you an example from one of the customer implementations I did, or let's say a customer that I worked for, many moons ago, right? So essentially, we had a Java application that used to talk to a front-end database, a in-memory database, right? That at some point of time, those records used to persist over onto an RDBMS database, aka Oracle, right? So that key value database or that in-memory database essentially was a key value database because transaction used to come like every second, right? And for that transaction to be stored, it has to be blazingly fast in memory, and essentially they were key value pairs. So if we try to persist them to some kind of a persistent storage, the time it takes to commit, the time it takes for the log writer to write the redo vector, the time it takes to
you're talking about an Oracle process there.
The Oracle process, yes. Mm-hmm. The time it takes to do all of that, right? Essentially, we are losing out on transaction, which means we are losing out on customers, and for this particular company, that's that loss of revenue for them, right? So I would say one of the use cases is if you're looking for, let's say, blazingly fast in-memory databases, key value pair would be one of them.
How about like every one of the social media systems?
Yep, absolutely. Social media system. Anytime you do a click on the website where you have to store, responses to a question, let's say yes or no, that could be one example for that as well. Any, IoT devices, Internet of Things, right? Any little piece of information that the IoT device collect, they're typically in this key value pair format. So the in-memory database.
So an IoT can be anything that's electronic, your refrigerator or
your smartphones, your
different
anything.
Internet of Things, on an airplane engine or anything, anything at the we call the edge. All of the different devices that exist today,
smartphones,
by the hundreds of billions and trillions in the world.
Right.
Fitbits.
Right.
So my question, though, Sudhir, is especially from a social media perspective, because I'm sure we have people worried right now, if those systems or those social media platforms are not using relational database management system that guarantees that kind of integrity in the data, how do we know that the integrity actually exists when people put their data into a social media platform or they interact somehow? How do we know? How do they know that it actually it's the correct data if that real deep integrity of the RDBMS isn't part of it?
I mean, that's a good question because if you don't have a good RDBMS or if you don't have a good database, with RDBMS principle, right, with asset qualities to provide that kind of data integrity, yes, absolutely, you're looking at loss of data here. So, your first thing or your first choice is if I do have an application like that, and if I do want to put a non-persistent, I would say, database in front of the application, the first thing that you want to do is have that persistent database, right, image right after the non-persistent.
So in other words, the data that's just sort of on the surface, which is most of it, can just sit there in a key value pair or some other store, and it doesn't necessarily need to be maintained with great persistency, durability from a perspective of the asset properties that I mentioned before. It's just not necessary, and so the decision can be made by the architects of the system to just simply keep that data that's often used right on the surface in memory, as you said before, and then the important data can be stored in back end in an actual real relational database management system, right?
Don't most companies use, I don't want to say both, but are there any companies out there? Yeah, most companies, especially bigger companies, from my observations, and I've been in the database market for a while, seem to use multiple databases. RDBMS is certainly going to be one of them. They might have some open source databases as well as commercial databases, but are there really any companies out there that are just using NoSQL?
That's exactly the right question. And let me put it this way, Steve and Sudhir, but to you, Sudhir, which one wins out if this is a long-term battle?
So I would say there is no real winner here, right? Because you have to look at it from a use case perspective, right? I mean, this was all about, a couple of years ago where people used to say, to cloud or not to cloud, or to virtualize or not to virtualize. This is the same argument here, right? To SQL or to NoSQL, right? And the answer is you basically need both. And let me give you an example here. Data is in different formats, right? The structured data is not the only data format that exists here. You have the text, the images, the visuals, the audio, and so on and so forth. So typically they have what's known as a data lake, where all these raw, unstructured data comes and falls, right? And yes, you do have the data warehousing where you're able to run analytics and business intelligence. But then comes in your AI, your Gen AI, the LLMs, the machine learnings, the DLs of the world here, right? And then if you have to run some kind of analytics, so let's say if you have to make sure that you don't have any hallucinations, right? Or you want your predictions to be grounded, right? You need these unstructured formats, right? to go back to and refer and say, hey, you know what? This is what the LLM model is spitting out, but is there any truth in that, right? And that's where these documents
ground
stored,
it. Yeah.
Exactly. You need to ground them in these unstructured format. These unstructured format could be your emails. It could be just a snippet of a text that you write in a notepad, right? Could be a Word document, could be something from the internet, right? But then this is what happens. And this is where the beauty of RDBMS and NoSQL database comes together. I would say the beauty of structured and unstructured, data stores, I would use the word data stores, they come together. With 23 AI, for example, Oracle, you have the Oracle database as vector
That's
databases.
an Oracle version, by the way.
That's an Oracle, yeah, exactly.
The present version.
For the present version, yes. So right now, you have the ability to store vector data, right? And those vector data in those vector tables can be indexed using vector indexes, right? So think of it. You have a text, which is, I went to the zoo, and we call that embeddings or tokens, and those tokens and embeddings can be then converted into vectors, right? And those vectors are tuples of so many numbers, right?
All right, wait. So hold on. We've got a couple of different. A tuple is a row. A vector is, at least in terms of general science, physics, a direction with a velocity. So is that the same thing here you're talking about?
In case of databases, basically a vector is a tuple, right? So if you think of a vector,
it's a row.
let's say
it's a row.
It's a row. So think of it as a row, but then it has a multitude of numbers in it, right? So it would be like 0, 1, 1, 0, 0. So that's how it goes, right? Essentially, you are taking a number, or you're taking a number for every attribute of that entity, and you're storing it as vector indexes. And what happens is, then you essentially, and let's say, for example, if your question is, which movie is the most watched movie in 2024, right? Then what happens is your query then gets converted as a vector. And that vector then gets searched in the database using the vector index. And whatever is nearest to that, the query essentially that gets thrown out, right? But then if we don't vet it against any of those unstructured data that I was talking about before, then all we just come out is just an answer. So back to you, Stephen, right?
So
we need to have them grounded.
A row is actually the answer.
Yes, the row is an answer.
Yeah, so the row becomes an answer, right?
Yeah.
So, yeah.
But then here, if you look at it, right, if I just had to query an Oracle database to find out which is the most watched movie in 2024, I may just have a set of answers, but that may not be the right answer, correct? So if I were to go back and compare it with the unstructured data that's out there and the internet, now I have a plethora of information that I can validate my input or my result against, and the result that I'm throwing out is now grounded. Right, so there are no hallucinations. So this is where I see the two worlds collide. Essentially, the unstructured and the structured world collide.
Not necessarily collide. It doesn't sound like. It sounds like
come
complement.
Together.
Sounds like complement.
Exactly.
Yeah, complement. Yes. Yeah. And in addition to vector databases, my understanding is that in terms of data management enabling, AI enabling data management technologies, it seems like knowledge graphs are becoming popular for grounding. And semantic layers as well, knowledge graphs based on graph database technology.
Correct.
So that was a perfect segue there, I think, Steve. So I want to sort of move this discussion, Sudhir, into AI. As we'll see in future episodes, I don't like the term AI because I don't think it's real, but I'll leave that as a teaser. I think it's a branding exercise, but we'll leave that as a teaser for later. But I do want to know if you think that AI, we'll use that term, is going to be capable or is capable at the moment. Maybe I'm behind the scenes since I haven't worked for 6 months in any major company. Is AI capable of making the decisions or making the determinations, without using the word decisions, as to which data belongs in a relational format versus which data can be in a NoSQL accessible format or even a more topical format outside of the obvious structured versus non-structured sets of data? What do you think?
So I don't think AI is at the point of time or has that intelligence, right? The AI doesn't have that intelligence.
So we still have a little ways to go with the machine learning.
Yeah. Not smart enough.
Yeah, it's hard enough to basically say, well, you know what, this kind of data belongs in a data lake. This belongs in a data lake house. This belongs in a data warehouse. This probably this probably is the best fit
Those
for,
are
let's
all
say,
different episodes coming up. Data warehouse, data lakes, all those things. Maybe I'll have you on, Sudhir, for it. So
yep. And then and even deciding whether a graph database is good enough, or let's say a row oriented or a column oriented, or let's say a document oriented. I don't think AI is at that point of time to decide which data falls in which data store or which bucket of the database, right? But I think
which category we'll
which
say,
category,
since,
right? But basically AI is on top of the data, right? Working on top of the data to make sure that any prediction that comes out, especially with RAG, is very close to the truth, or at least what seems as the truth, right? And there are no hallucinations to that.
Let's talk about RAG. So RAG stands for Retrieval Augmented Generation, correct?
That's correct.
And why is RAG becoming so popular in the LLM, large language model, and kind of Gen AI space?
And let's explain large language model and a small language model. It's basically the language we speak. Right?
Correct.
So the language we speak can be used as a programming language as part of the basic principles of generative AI and all those products that you see and know so well out there. So go ahead, Sudhir.
Yeah. So, I mean, if you look at the definition of LLMs that's out there on the internet, they basically define that as a probabilistic model of text, right? So essentially, if you have a model, let's say you have a sentence, I went to the zoo, and I was explaining it as I explained that earlier, right? Essentially, those words or segment of the words are called tokens, and those tokens are broken down into what's known as embeddings, right? And those embedding are those vectors, those tuples that we were talking about that get stored in a database. And essentially, you are now searching the proximity of another vector to this particular vector to throw out the best possible answer to your query, right?
So that's, as an example, a large language model is English, and the systems are good enough right now to understand the difference between Jersey Steve and I speaking New Jersey versus you speaking in San Diego.
Absolutely. It can, and there are a lot of use cases for LLMs. For example, right, if you have to, let's say, translate text translation, sentiment analysis, right? If you have to do all of that, I mean, LLMs are very great at that. And then there's a whole different topic about LLMs, and
and we're going to have episodes just on that. So I don't want to get too much into that, but
transformers and so on and so forth, right? But with RAG, what the value that RAG brings to the table is that entire fact that it I won't say it takes away hallucination. I would say it reduces hallucination, right?
So
the very fact I think of it. Yeah.
Giving the wrong answer. You know, when you look up something using one of these large language models and it gives an answer that seems like it might be right, and if you don't know, you might think it's right. You know, it gives you a confident wrong answer, basically. That's a hallucination.
Yeah, exactly. So basically what happens is LLM, the large language models are trained on oodles and billions of data across the internet, right? And that's basically what happens is the next time you throw it and you see that this is how it happens from an LLM perspective. You train it on a lot of data, and then once it's trained on a lot of data, these foundation models, once it train a lot of data, then you let it loose on your own proprietary data and hope that the answer it spits out is the best possible answer.
And by training, you mean allow for enormous amounts of arithmetic, iteration, extrapolation, and interpolation over periods of time to come up with a most probabilistically likely answer.
Yeah. So for example, Llama 3, and don't hold me to this, but Llama 3, I think, was trained on like 540 billion parameters or tokens, right? And those tokens are words. So
sounds like the US budget.
Exactly. So that's the amount of data it's trained on, but that does not mean that the answer it spits out or the answer it throws out is the right answer, right?
Just so, for example, the U.S. budget, we might spend billions on something and still get it wrong. In fact, we often do. Yeah. I digress.
So many, in fact, there are examples out of the internet where people basically asked the large language model about on which side of the road do people drive in the United States, and it said basically that people drive on the left side of the road. Which is completely incorrect, right? We drive on the right side of the road, and the rest of the world, it's the other way around.
Hey, look, we come from Jersey, and we've been driving on Saturday nights for years. So, hey, that might, you might not totally be right there.
Exactly. So what then happens is once you have the answer, you don't just give the answer back to the person who asked you this question. you go back and you verify it, right? So you question the veracity of that answer, right? And that's what RAG is. You essentially go to those document stores, you go to those emails, you go to the text documents, you go to every other facet of information around the world and say, is that correct? Is that correct? And once it gets vetted out, right, the answer could be yes or the answer could be no. So it comes very close to reducing hallucination, but that doesn't mean it eliminates hallucination. The only way to eliminate hallucination is to make sure that the RAG database is like unlimited, and which is not possible because you cannot be vetting this answer for many days. You have to give the answer back to the user, so there'll always be some element of hallucination in most of the answers.
It's still a best guess. It's a good guess.
Still the best guess,
but it's
the
still
probability
a best guess.
game.
Yes.
You know,
that's the probability game.
So, yeah, it'd be interesting.
Yeah, go ahead, Steve.
No, it'd be interesting if some of those systems actually just gave you the probability number. You know, so you could take that into consideration.
What LLMs are. That's what LLMs are. That's what AI is, probability. It's all about probability statistics, right?
Well, yeah, I think what you're asking, Steve, is you would like to see, and this is a great idea, and again, we'll get into this with different episodes, but we'd love to see a percentage of probability of accuracy for an answer.
Yeah, like in the space movies, like, you know, 99% probability or whatever that such and such might happen.
Or like when they do an echocardiogram on an artery that I have, and it says that I'm blocked 75% plus. The detail is in the plus. That's what we like to know.
Right. And I think things are getting better here because they just released, or the concept of agentic RAG came out, where essentially, you don't have to have
every major company in the world is claiming that they invented that. It's a lot of fun listening to this.
Agents, so AI.
Yeah, the agentic RAG as of now. The agentic RAG as of now, where you have these meta agents, like the master agents, and then you have these the worker agents, right? And then making sure that the worker agents verify all of these facts, and they go back to the master agent and say, I think it's 98% accurate for you to give the answer back to Steve, Don, and Sudhir, and that's how it comes back to us. So I think that's I think that's the next direction of the industry, to make sure that the agentic RAG is error prone before they move on to the next thing. So this is very interesting.
You know what?
How close is that to being legit in the business world and in our personal lives? Because it seems like it's a ways off to me, as far as we're
already in the science fiction world. So how close is this to being real? Do you think?
I don't think it's close to being real, because there is nothing close to being real. Right? I mean, you can have oodles of agentic AI, multitudes of agentic RAG working all there, and I don't think they can come as close to the truth. And this is again, in my opinion. So, and we are ways off here, right? It'll take years for us to get.
In the Don Sullivan Show, it's all about opinion and idea and discussion of science, technology, and computing. And, Sudhir, you perfectly answered. The last question I was going to ask is, where is this all going next? And we've already had that discussion, and that is absolutely wonderful. And what I want to do is I want to end this off for the audience and saying that we've been through a few episodes now. We thank you all for listening. We're going to have an expanded set of subjects that are going to be on the Don Sullivan Show. We are going to have an expert who has been around this industry for a very, very long time talk about, for example, what he got wrong, what he thought was going to happen, and what didn't happen over the last 50 years. And that's going to be fascinating. We're going to have an individual who has built and sold multiple startup companies talk about what it takes to actually build a startup in 2025's modern technology world. We're going to have a number of other subjects, including we're going to have Sudhir come back on at a totally different subject, and he's going to talk about why heavy metal music makes so much sense to certain people, and it doesn't make much sense to me at all unless I'm listening to Enter Sandman and Mariano Rivera is coming in to save a game, as he did 652 times.
It always makes sense in my car, Don. Yes. It always makes sense over here.
And Stephen will be much more adept at posing those questions to Sudhir, and I'm just going to sit here fascinated while that's going on. But until then, folks, thank you for listening to the Don Sullivan Show. Thank you, Sudhir. And as always, thank you, my buddy, Jersey Steve. And until next time, be smart and learn.
See you soon, folks.